as said, we're going to talk about DBeam and how to this tool to export SQL tables into Avro records that uses Beam SDK under the hood. I'm Luis Bianchim. I'm a software engineer at Spotify. I've been working at Spotify for 4 years. I'm based in Stockholm, Sweden, and I've been exposed to Beam SDK since about 2017. So in this talk, we're going to go through the need for DBeam, an overview of what it is, how to use it, our road to build DBeam, and some final remarks. So at Spotify, since we moved to Google Cloud in about 2017, we started using Beam SDK and also Google Data Flow for data processing. And also we built the Scala DSL on top of Beam SDK called Shio. So usage of Beam SDK and data flow is very spread at Spotify. But we also had some SQL databases that we need to make this data available for further data processing. So our need was to export this from the SQL database into Avro files in Google Cloud Storage. And some of the use cases were around accounting and financial data. And we export this data, we can do some data processing and also load into Google BigQuery for data warehousing and some ad hoc analysis. And I said 2017 because that was the time when we used to have one of the biggest Hadoop clusters in Europe, but we were moving to Google Cloud. So we had a bit of Apache Scoop sports and using Hadoop clusters to run this, but it was no longer adequate to use it. So we want to turn to something based on Beam SDK. So we've been build DBeam, which is open source since 2017. It is a command line interface. It is shipped as a jar and is implemented on top of Beam SDK. And when you run DBeam, it's basically opening a JDBC connection, querying a table from the database, iterating through the rows of this table, and converting and writing the data into an Avro file. And it can use any Beam SDK runner. And in our case, we use mostly Dataflow, let's say. And as I said, it was released as open source in November 2017. So we've been running it in production for quite some time. At Spotify, today we use different teams. About 20 teams use DBeam in about 100 daily exports. And some of the biggest exports would export 500 million records every day. And this bigger export would take around 30 minutes to 3 hours. But there are also very smaller exports taking like 3-5 minutes with small data. And we've been running this daily in production since August 2017. But in Spotify, we also we take the DBeam core open source jar file. We also pack with some scripts, and we build a Docker image for DBeam, and this interfaces with the internal Spotify systems. It also checks for upstream dependencies and publishes the data into our internal system. And it is packaged to run on Sticks, which is also open source, and it's our cron service. So you can schedule this Docker image to run, let's say, every day around 2 a.m. UTC, let's say. And when it runs, it will trigger DBeam and run a Dataflow job performing the export. So Dataflow job, or sometimes a direct runner. Yes. So one example of how we use DBeam with Sticks. In Sticks, we can define these YAML files where we configure workflows. So here we configure one workflow saying that I'm going to run daily at 2 a.m. and we say which. So we say to run a export using the Beam SDK here with this image in these commands. And we also configure the authentication to use a service account, and so that it can connect to the database, or also decrypt secrets for the password to the database. And it also has is authorized to write to Google Cloud Storage buckets and to trigger the data flow job. So it has all these permissions. And when it runs on data flow, it looks like a very simple job graph. Is basically prepares the query and runs the query and exports to Avro records. So it's not a very simple job graph. And it also exposes some metrics like how much time it took to export, how many records were exported, and how many bytes were written. So this can be used to roughly know how much data is being exported, but also what is the throughput of the Beam. And if your data grows, then this can serve as an indication that you might have to restructure the data, how you export or how you persist the data in the database. And our road to the Beam, as I said, we used to have Apache Scoop, which is built on top of Hadoop to run as a Hadoop job to export from SQL database. Then we built a bit of some scripts on top of Scoop to run on sticks, but this was still using our legacy Hadoop cluster that had to be shut down. So we need to find some other solution. So we also tried to run in Python, some Python scripts, some Bash scripts, and PostgreSQL. So they are quite nice, up to a few thousand records, but they don't scale for millions of records. And then when we started building the Beam, we first implemented in Shio. That's our Scala DSL on top of Beam SDK. Then we end up writing Scala and Beam SDK, and later we turn it in just Java and Beam SDK, which was just faster and simple to maintain. So as I said, simple script with Bash or Python or PSQL, it works well and nice up to, let's say, 100,000 records you're exporting. But after that, it's not nice. Doesn't scale. When we first started writing the Beam with Shai, or even like with native Beam SDK, it did not scale because we were trying to use JDBC IO read and compound with Avro IO write. But the problem here is the JDBC IO read would read all the records into a sort of a single bundle in Beam, and this would lead to a huge fan out of data, and would lead to out of memory. So before it starts to write to Avro, it would read everything into memory. So the read operation was taking all the records, and it did not scale for millions of records. So what we end up doing was mostly piping some libraries together, Beam SDK, JDBC, and Avro. It handled these type conversions between SQL type codes into Java types and Avro types. And we also have to handle nulls, because on the JDBC driver, everything is nullable. So we also have to, in the output, put everything as nullable. And at the end of the day, what the Beam does is it reads and transforms and writes into a single loop in a single bundle, single DFN. And while it does that, it also counts and runs some measurements of how long does it take to run the query and to export. And moreover, we also need to tune the JDBC connection, because sometimes if you don't tune JDBC can eagerly fetch all the records into memory, and that will not scale for millions of records to export. And another aspect we try to be careful about is to avoid silent failures. So to validate the arguments and provide good error messages before running the export. Some recent features that were added are parallel exports. So exports can be run in parallel. So it will run multiple queries in parallel. And usually this is done, it's similar to Apache Scoop, that it will partition based in a column. It will divide the into multiple queries, filtering different segments of the table. Another feature is it supports a custom SQL file, so that you can customize the query and not just target a table or a view. You can customize the query you want to run. And you can also customize the schema that it will write to. So by default, DBeam will auto-generate the schema based on the input table, but with this you can customize, add more, let's say, documentation and possibly some different types on the target schema. So in the future, some other things we had in mind is possibly to import into the SQL database. That's the reverse of what DBeam does, just exporting. And possibly consider other export formats, let's say protocol buffers, Parquet. We hadn't had a need so far for it, but that's something that it could be possible. And also to improve the setup and configuration to be able to define other ways to configure DBeam. So to recap, when can you use DBeam is when you want to export data from PostgreSQL, MySQL, or databases, and you want to export to Avro files for further data processing or data warehousing. And it's very appropriate when you're already using Beam SDK in your team or in your company, and you already use some of these their runners. So best support. It provides best support for Direct Runner and Dataflow Runner. So if you already use Dataflow Runner and Beam SDK in production today, using DBeam will be very natural to operate. So some references. Here you can find the project at GitHub, github.com/SpotifyDBeam. And I should also remind that we are hiring at Spotify. You can find the open position at Spotify jobs. And you feel free to reach out for further questions. And yes, we're open for questions. Yes, so there is a question about why the child solution. Do you want to read the question, or should I? Sorry.
It's okay, you can read it.
Okay. So there's a question on why the child solution did not scale. Are not the Scala API built on top of Java API? Yes, that's right. So the issue was not about child API. It was just the way we are using the Beam SDK, that we are connecting, as I said here, both the JDBC IO and Avro IO. And we had to go down to the Beam SDK to implement our own doFN and ptransform. So it wasn't about Shire. It was about that we need a lower level usage of Beam SDK for it to work. All right.
Right. Do we have any more questions? Okay. All right, so we are gonna end up the session. If there are more questions, remember that you can ask them in the Slack channel. You can join on the link that is displayed here in the live stream. And also, I want to. Oh, do we have one? Yes. You can read it, Luis.
Yeah, so could the beam potentially be altered to string JDBC tables to streaming sinks like message queues, PubSub, Kafka, Kinesis? So that's an interesting question. Could it be altered? Yes. So when I read this, I think there was a colleague that he had an idea to sort of, if you want to try this, you probably want to use the replication protocol from the database and take all the changes happening on the database and post to some other like message queues, PubSub, and Kafka. So yes, but I don't know how exactly that would work. But feel free to reach out for further discussion.